Brad Williams, Excel Prime. Regression analysis. I'm just going to cover the very basics. If you need additional information, bust out your stats book. Anyway, regression. Use this regression tool to calculate a regression analysis. This is the layout. This is the data output based on dependent and independent variables. Depending on how you set this up, you have your intercept, you have your x's and your x's. So we have x1 and x2, and then you multiple r squared, adjust for r. I'm not going over all of this. It's too detailed. I'll just go over quickly some of the stuff. Let me just give you an overview. Regression analysis, you use it to forecast the future, build predictive models, and often make sense of what seems like random data, where regression can make sense of this data. Regression analysis enables you to determine the extent to which one range of data, the dependent variable, varies as a function of the values of one or more other ranges, the independent variables. This relationship is expressed mathematically using values that Excel calculates. You can use these calculations to create a mathematical model of the data and predict dependent variable by using values of one or more independent variables. This tool can perform simple and multiple linear regression and calculate and standardize residual automatically. What does that mean? Regression is a powerful tool. There are courses just on regression analysis in Excel. What we're doing is just showing you the output. Inputs for calculating this data are down here. This is the dialog box. We have the input, the range that contains the dependent variable, the X range, one or more ranges that contain independent variables. In other words, let's say ADV is your dependent variable, and then basis point difference and deposits are your independent variables. You would put B, the range B here in Y, and then your other data as your independents. Now, there's a lot of third-party statistical software packages that make all of this, everything here, all of the different variables here available in one simple input. It will spit out all of this data. Sadly, Excel is back in the 70s and they elect not to upgrade. I guess they think it's easier just to let third parties, the smarter third parties, put together these packages and sell them to individuals like me and you. But again, if you want to use this tool, it's available for free within your Excel. Back on topic, constant is 0. If selected, forces the regression to have a constant of 0, which means that the regression line passes through the origin where the x values are 0. The predicted y value is 0. This is a subject that is very complex, and you need to read up if you want a constant 0. The confidence level, you're down here, confidence level. The confidence level for the regression. The residuals, the 4 options in this section of the dialog box enables you to specify whether to include residuals in the output. Normal probability generates charts for normal probability plots down here. And here are your residuals. As noted here, I know this sheet is busy. There's not a lot I can do about it. I just need to try to get this information to you. In addition, we have plots. So there's just a lot of data here. So let's go ahead and set this up. I'm not going to print this out. I'm just going to show you how to set it up. Well, actually, what I'll do is I'll spit it out to a new worksheet. Let's go to data, data analysis, go to regression. Here we have the input, B1 to B23. X variables, let's go BP. Is this going to take labels? Yeah, it'll take labels. We're not going to deal with the confidence level. We'll say 95%. We'll put this on a new workbook. We don't want to print residuals, normal probability plots. I'm not going to worry about that right now. We'll hit OK. There's the output. I'm not going to explain the output. That would take too long. This would be a multiple regression because why? Well, if we go back here, we have the dependent variable, then we have independence. We have multiple, so therefore it'd be a multiple regression. If it was just B and C, it'd be a simple regression. Here we have multiple independent variables, as noted here, as I just said. ADV is the independent variable. The dependent is deposits. I went a little backwards here. You can set this up any way you want. I set it up as ADV as being the dependent variable, and then C and D as the independent. You can assign any dependent variable and then any independent variable. Below, you're going to find the different plotting. Here we have residuals. We have a probability plot. We have this variable plot. If you have the deposits, you want to know if there's any relationship there. What's the distribution? What you can do is you can just run a histogram. You can run any number of tests to just get a picture of what this looks like. So if you grab this, normal packages, you could just hit histogram and it would spit out a histogram. It'll give you an idea of this distribution. Remember, we have buckets. So we put these in different buckets. For example, let's say they're in $250,000 buckets or $500,000 buckets from 0 to 5 million. You would see a distribution, and then from there, you want to see what's our average? What are we trying to accomplish here? And then from there, what's the 90th percentile? What is the 25th percentile? For 1% move in deposits, how does that change this other information? So that's what we're trying to find here, and that's what regression is great in terms of analysis. Brad Williams, XL Prime.